guys. So this is the lesson from Friday, which was on function operations. And so what we're going to go through and do is I'm just going to go quickly through these examples so you guys can watch this if you get confused. So at first we talked about just domains. So the domain is like the x values that you can plug in to that function. So for like f of x, that's just a standard linear equation. So any x value will work, okay? So if any x value will work, we call that negative infinity to an infinity. Same thing with this quadratic one here, okay? It makes that U shape. Well, you can still plug in any x value. It doesn't matter what the quadratic equation is. The domain is still going to be negative infinity to infinity. The only time that your domain will not be negative infinity to infinity is if we are dealing with fraction answers, and we'll talk about that in a little bit. Okay, so we're going to add it first. So the first one says f of x is 2x minus 7. And we are going to add h of x, which is 5x plus 1. So we are just going to combine like terms. So we get 7x, and then minus 7 plus 1 is minus 6. So 7x minus 6, and that's the answer. Okay, g of x, if we do that one, 3x squared plus 7x, and then we're going to add f of x, which is 2x minus 7. Combine like terms, so 3x squared, the 7x and the 2x combined to give me 9x, and then don't forget the minus 7 at the end. So it's just combining like terms, nothing major there. With subtracting, it just gets a little trickier, but not a lot. So if I take h of x to be 5x plus 1 and f of x to be 2x minus 7, you have to remember to subtract the entire quantity, which means you're really distributing that negative. So this becomes 5x plus 1 minus 2x plus 7. So the 5x minus the 2x gives you a 3x. The 1 plus a 7 gives you 8. And that's subtracting. Multiplying, if I take 2x minus 7 times 5x plus 1, that's a binomial times a binomial. Remember, you have to FOIL. Okay, so first times first is 10x squared. First time, or the outsides are 2x times 1, which is 2x. Then we do the insides, which is minus 35x. And then finally we do the last, which is minus 7. Combine your two middle terms, so you get 10x squared minus 33x minus 7. And that's multiplication. Last one is division, and this is where we really need to worry about our domains. So if I do f of x, which is 2x minus 7, over h of x, 5x plus 1, that's the answer, okay? But what we have to worry about is that denominator, okay? We have to make sure that it can't be 0, because when it's 0, a bomb goes off and our equation explodes. So if I take 5x plus 1 and I set it equals 0, I subtract 1 from both sides and I get 5x equals negative 1. Divide by 5 and I get x equals negative 1/5. So when x is negative 1/5, that's going to make the denominator 0, which is going to cause the explosion. Okay? So really, x can't equal negative 1/5. So when we start talking about our domain, if we think about this being a number line, with this being negative infinity, and this being infinity, and this being negative 1/5, we can be walking along, plugging in any x we want, and we've got one of those little mind field sensor thingies, and the sensor goes off, and we're like, oops, gotta walk around the little mine so we don't explode, and then we can keep going. So our domain goes from negative infinity. At negative 1/5, we have to walk around our explosion, and then at negative 1/5, right after that, we can keep walking, and we keep going to infinity, and then we union those. So that's the domain. You got to make sure you don't explode. So that was really all composition functions. We had to do, I'm going to do the second one too. So h of x equals 5x plus 1. And g of x is 3x squared plus 7x. And the reason I want to do this one is because in that bottom, you have to take out a negative. Or an x. So when I take out an x, I get 3x plus 7. So that's really your denominator, okay? So when I'm doing my denominator, I have to see when x equals 0 or when 3x plus 7 equals 0. Because I want to make sure, because if I multiply those two things, it's going to make the whole bottom 0. So x equals 0, that's already done. So really x can't be 0. And then on this one, we subtract 7 over. So we get negative 7 divided by 3. So negative 7 over 3. So x can't be that either. Okay? And that's really it. That's all we're doing there. When we do our domains, remember here is negative infinity. Here's negative 7 over 3. Here's 0. And then infinity is this way. So when we're walking and walking, go around the mine, walk, 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 around the mine, walk, walk, walk. So negative infinity to negative 7 over 3, walk around the mine. Negative 7 over 3 to 0, walk around the mine. 0 to infinity, walk around the mine. And then we union all of them. So this one will have 3.